Good morning, students. Today we discuss about new chapter, that is chemical bonding. Chemical bonding. So what is chemical bonding? The force of attraction which holds two atoms together in a molecule. For example, this is an atom. This is an atom. So this is molecule. In this molecule, this is an atom, and also this is an atom. So in between these two atoms, the force of attraction which holds two atoms together is called chemical bonding. The force of attraction in between, the force of attraction which holds two atoms together is called as chemical bonding. So what happened in chemical bonding? In chemical bonding, attractive force and repulsive force. So both are in equilibrium. So attractive force and repulsive force both are in equilibrium. So that will happen in the chemical bond. So just to discuss about what is the necessity of chemical bond. I will explain. What is the use? What is the necessary to form the chemical bond between two atoms? So here atoms are H plus H gives rise H2 molecule plus 434.72 kilojoule per mole. So here this is hydrogen is atom. This is hydrogen is atom. This is hydrogen molecule. This is molecule. Here this is another atom. So here atoms are high energetic and less stable. So these are high energetic and less stable. High energetic and less stable. Molecules are less energetic. So these are less energetic and more stable. Less energetic, more stable. So that's why atoms are combined with each other and form the molecule. This is about the formation of chemical bond. That is the use of chemical bond. After that, so next time the graphical representation is there for reference. So this is the graphical representation. So attractive plus repulsive force, attractive plus repulsive force, that is called as potential energy, and internuclear distance. When you observe this graph here, like this. So this is the graph, and up to here, so bond energy and this is bond length. This is bond energy, and this is bond length. So here it is formation of chemical bonding is exothermic reaction, and also potential energy is decreases. Just you want to remember these two. Chemical bond formation is exothermic and also potential energy is decreases. Just you want to remember these 2 points. After that, therefore, exothermic means delta H value for this is negative. Therefore, this is the formation of chemical bond. So, chemical bond formation is explained by one theory. That theory is called valency theory or valency. We will discuss about kossel-Lewis theory. So here we'll discuss about kossel Lewis theory or electronic theory of valency, and also next one, chemical bond theory. So what are the chemical bond theory? So to explain about the valency means combining capacity of an atom is called valency. Combining capacity. For example, in NH3, valence of nitrogen is 3. In Cl2O7, chlorine is 7. Like that. So combining capacity of an element or atom is called as valency. So valency is of two types. First one is covalency, and second one is electrovalency. Covalency means number of sharing electrons, number of transfer electrons. So this is called by this covalency, the resultant bond is called covalent bond. So covalent bond, and the resultant bond is called as electrovalent bond. Electrovalent bond is also called ionic bond. This is about ionic bond. Therefore, this is the valency. So here, if you take any element, outermost electrons are called inner electron. Outermost electrons are called valency electrons. So here, these shell electrons are called valency electrons. So these electrons are called core electrons. Inner core electrons are called core electrons. Therefore, here nucleus plus core electrons are called kernel. So nucleus plus core electrons are called kernel. So outermost electrons, 8 electrons are there, that is stable electronic configuration. If the element having 8 electrons are NS2 NP6 configuration, that is stable. So that rule is called as octet rule. These are explained about the electronic theory of valency. So valence is mainly divided into covalency. Number of sharing electrons to attain 8 electrons is outermost. So number of transfer electron, whether it is loose or gain electrons are called electrovalency. So I will give an example for this also. After that we will discuss about covalent bond and electrovalency bond. So outermost electrons are called valence electrons. Inner core electrons are called core electrons. Nucleus plus core electrons are called kernel. So here I will give an example for this. So only valence electrons are responsible for the chemical bond formation. Only valence electrons are responsible for the chemical bond form. Chlorine. So if you take chlorine 17, 1s2, 2s2, 2p6, 3s2, 3p5. Therefore, how many electrons? 1 electron is needed to get the stability NS2, NP6. Therefore, chlorine 1, 2, 3, 4, 5, 6, 7, and one more chlorine 1, 2, 3, 4, 5, 6, 7. These two are sharing this electron. Therefore, chlorine covalency sharing electron is 1. But in case of sodium, it can lose one electron. Sodium 281 minus one electron, you get Na plus 28. Therefore, it is called electrovalency, losing electron. Chlorine 287 plus one electron, then it converts into 288. Therefore, number of transfer electrons are losing or gaining. Electrons are called electrovalency. So this is about electronic theory of valency. Electronic theory of valency. After that, so if two elements are electronegative elements, X is electronegative element, Y is electronegative element, the bond is covalent bond. Example, chlorine, and this is also chlorine. Therefore, this bond is covalent bond. Next one is electronegative element, other one is electropositive element. That bond is called ionic bond. Example, chlorine and sodium. So therefore, this bond is called ionic bond or dative bond. Sorry, this one is only dative bond. So after that, next one, electropositive, two are electropositive element, that is metallic bond. Sodium in between sodium, that bond is called as metallic bond. Therefore, two elements are electronegative elements, the bond is called as covalent bond. Two elements are electropositive, that bond is metallic bond. If one is electronegative, other one is electropositive, that bond is called as metallic bond. So after that we will discuss about the valence electrons are intimated by Lewis. That method is called as Lewis dot method. So Lewis dot method. What is Lewis dot method? I will explain. Lewis dot method. Lewis dot method is useful to express valency electrons. Useful to express valency electrons. So therefore, number of valency electrons. Example, dot structure. So one hydrogen will write like this. Two valence electrons. Two means what are going to be? Helium, two electrons. Third, beryllium also will take it. Next one, third group elements. Any third group elements? Boron. So boron have 3. Four elements. Carbon having 4 like this. So this is the electron dot method to represent the valency electrons. For example, chlorine 1, 2, 3, 4, 5, 6, 7. Nitrogen 1, 2, 3, 4, 5, 6, 5. Nitrogen 5 like this. This is the electron dot method of Lewis dot structure. So this is about oxygen. For example, if you take oxygen 1, 2, 3, 4, 5, 6. So phosphorus, the valence electrons are 5 like that. So this method is useful to express the valency electrons. So this is about chemical bonding introduction.